Graph paper is key here. Okay, so I'm going to show you. So this is called analytic geometry because we're taking circles and we're analyzing them in the coordinate plane, basically.
Are we using that link to graph them?
The equation? Yeah.
That would be used.
Circles are pretty straightforward.
The parabolas were hard.
Okay, it does get more difficult when we get to parabolas because there's so much information. But these are, what two pieces of information do we need for a circle? Okay, we need the radius, length, and we need to locate it. How would we locate a circle? What's that called? The center. And we're going to note that as a coordinate with HK. It's an XY coordinate, but it's a special one. So that's just what your book uses. So we're going to roll with it. The equation is that there. Good.
Oh wait, no, come on.
All right, so what is the center of this circle we're on? What are the coordinates?
2, 1.
Right. So this is the H value and the K. So 2 and 1. And then what's the radius? Think vertically, horizontally here. We can count spaces. There you go. Okay. Yeah. There's your equation. Okay. So we have, it locates the circle and it tells us how big it is. That's the idea. Right? Let me show you. Okay, so this is the same thing. It's just a little bit more graphical. Okay. So I can change the radius. I do it right. Right. I can make it bigger or smaller. And I can change the location of the center. Okay, so there's my circle. Here's the equation, which I just showed you, right? And then if I put it on a grid, the center of this one is 3, 2. And the radius is 1, 2, 3, 4. So we have our equation. X minus 3 squared plus y minus 2 squared equals 4 squared. Okay. Anything you do here, you can change the radius, it changes the r, and that's it. Okay. So it's another way to look at it. Okay, so let's do that. What do you want the center of the circle to be? 2 what?
2.
I guess I'll pick. Radius. Ooh, you are fun. It's gonna be 12 units across. So we'll need to use a. Sorry. Six.
That was actually 7.
All right, so center's 2, -3. That's the easy part, right? Here's how I like to graph circles. The radius is 6, so go out 6 faces each way from the center. So 1, 2, 3, 4, 5, 6. All right, so there's your kind of your reference. You can use a compass. Or you can just be perfect.
Look at that circle.
Best circle I ever drawn freehand. We have your circle.
It kind of looks like.
Mine used to look retarded.
Look at mine, Art.
Like I said, it's probably the best one I've ever drawn. Okay. Could you? Here's my question. Could you draw a circle from the equation? So if I gave you, this one would be x minus 2 squared plus y plus 3 squared equals 36. If I gave you that equation, could you do this graph?
Yes.
Okay, 2, 3 people could. Okay, so the radius is the square root of 36. Yep. And what's the center? No.
2, -3.
There is the tricky part of the equation. It's the opposites. 2, -3 is the center. Okay. Be careful. Is that all you need? That's all I. Yeah, that's all I'm gonna do today. Okay.
Is that the homework?
I'm getting there. Slow down a little bit.
Where are you?
Yep. Let me take a couple of those off of there. Five through 7. 12 through 14. So you're going to have to think a little bit more than this on a couple problems. Do you remember what a tangent line is?
And the circle is like a circle.
It touches it, yeah, it touches it once. So where are the tangent lines of this circle? Or where is one? Okay, so one of the problems asks you, what's the equation of a circle with center this and tangent to x equals 3? You just have to read into that, okay? You just have to figure out the radius from that. Another, the circle passes through the point 1, 5 and has its center at negative 2, 1. You have to use the distance formula to find the radius. Okay. And then the endpoints of a diameter, so you'll have to use the midpoint formula to find the center. Okay, so continue to think that 10-1 is going to apply here. And if you have any questions, say so.